GATE 2018 Civil Engineering Set 1 question number 40. Consider the deformable pin jointed truss with loading geometry and section properties as shown in the figure. So we can see that here we are given a truss where let's say this is joint C and this is joint A and this is joint B. The axial rigidity of the member AB is A, while the axial rigidity of the member BC is A, and the axial rigidity of member AC is 2A. Here a vertical load 2P is acting at joint C and a horizontal load P is acting at the point C. Here here is a roller support, and at point B there is a hinge support, and the length of all the members are given in the question. Given that the E value, Young's modulus value, is 2 into 10 to the power 11 Newton per meter square, area is 10 mm square for all members, length is 1 and P is 1 kilonewton. The horizontal displacement of joint C in mm up to 1 decimal place is, we have to find it. Reference to the relevant NPTEL courses and video has been cited. Now coming to the useful data, to find rotation of any member, we apply a unit couple here. A unit couple may be anything. It can be horizontal load, or it can be a vertical load, or it can be a moment also. Then this is our first step, that to find the rotation, or we can say displacement, we apply unit couple, and in the second step we will find forces in all members due to unit couple, find forces in all members due to unit couple. The rotation or displacement, we can say the rotation or displacement of member is given by delta, or we can say theta, equals to summation P into K into L upon A into E, where P is forces in all members due to applied loads and K is forces in all members due to unit couple. So using this formula we will find the displacement in the truss. So this is virtual work method. Now coming to the video solution, using the principal virtual work method, we will find the forces in the member when the actual load is acting. So this is a case of when actual load is acting. So as you can see here that here it is joint C, and this is joint B, and this is joint A. So as this is a roller support, so here when reaction will be acting, let's say the reaction acting here is R1, and at joint B will be two reactions, one horizontal and one vertical. So let's say the reaction here is R2 and one horizontal reaction here is R3. Now we will use the three basic conditions we normally use for solving a particular truss or beam, which are summation fx equal to 0, summation fy equal to 0, and summation mz equals to 0. Now if we use the summation fx equal to 0, we can see here that R3 equals to P, but as we know that the value of P is 1 kilonewton, so R3 will be 1 kilonewton. Now if we use the summation Fy equal to 0, R1 plus R2 equals to 2P, which we can also write R1 plus R2 equals to 2 kilonewton. Let's say this is our equation number 1. Now if we use the summation Mz equal to 0, and let's say we find moment about B, so we can write it as summation moment B equal to 0, means moment about point B will be 0. So we can write it like R1 into L plus 1 into L equals to 0, means now if we solve it, we will get R1 equals to minus 1 kilonewton. Now if we use the first equation, we will get R2 equal to 3 kilonewton. So we can see here that R2, which is 3 kilonewton, is acting upward, and R1, which is minus 1 kilonewton, so it will be in downward direction. So we can write it here 1 kilonewton, and this is P equals to 1 kilonewton and 2P will be 2 kilonewton. Now if you see the joint B, we can see here that the forces in the member BC will be FBC, and there is a horizontal reaction R3 will be 1, force AB will be FAB, and there is a vertical reaction R2 here is 3 kilonewton. So now if we solve it, we can see that FBC is minus 3 kilonewton and FAB is minus 1 kilonewton. These are the forces in the member AB and BC respectively. Now if we see the joint A, we can see here the angle is 45 degree, because both are the distances are same, so it will be 45 degree. So this is member AC and this is member AB. So here the forces in FAC member will be FAC, and here the horizontal reaction is 1, and there is a downward reaction R1 is 1 kilonewton, and this is also 1 kilonewton. So force in the member AC will be root 2P. Now if you solve it, we will get FAC also root 2 kilonewton. So these are the three reactions in member AB, BC and AC respectively. Now as we have to find the horizontal displacement and C, so we will apply a unit load here. So here we are applying the unit load and we will see the forces in the member. So let's say one unit load acting in the horizontal direction, and now if we solve it using the basic equations like summation fx equal to 0, summation fy equal to 0 and the moment about a particular point equal to 0, so we will find, let's say this is r1 and this is the reaction here is r2 and one horizontal reaction here is r3 will be 1. So we can write r3 will be 1 because we know summation x equal to 0 and r1 plus r2 will be 0 because there is no vertical force acting. So let's say this is our equation number 2, and if you find the moment about B, we will get 1 into L plus r1 into L equals to 0. So we will find r1 equals to minus 1 kilonewton. So if r1 is minus 1, so r2 will be plus 1 kilonewton. So here r2 will be 1 kilonewton acting in the upward direction, and r1 will be minus 1, so it will be acting downward, and r3 is 1 kilonewton. Now if we see the joint B, we can see that at joint B the horizontal reaction is 1 and there is a member BC. So force in member BC will be FBC acting upward, force in the member AB will be FAB, and there is a vertical reaction R2 here which is 1 kilonewton. So we can see here that FBC will be minus 1, FAB will be minus 1 kilonewton, and likewise in the member AC it will be similar to the previous system. We can write it like that also, that force in the member AC FAC will be root 2 kilo. So these are the three forces when the unit load is acting. Now we have all the forces in the member due to, this is actual load and this is due to unit load. So forces in member when the actual load is acting, in member AB it was minus 1 kilonewton, and in member BC it was minus 3 kilonewton, and in member AC it was 2 kilonewton. And due to unit load in member AB it was minus 1 kilonewton, in member BC it was minus 1 kilonewton, and in member AC it was root 2 kilonewton. The length of the member AB is L and length of the member BC is L, and using the Pythagoras theorem, member AC it will be root 2L. The axial rigidity of the member AB is A and axial rigidity of the member BC is A, but the axial rigidity of the member AC is 2A. Now if we multiply it, the summation PKL by AE value we will get, this is L by A, this is 3L by A, and this is L by A. Now if we, the summation will be 1 plus 3 plus under root 2 L upon A, so this will become 5.414 L upon A. Now if you put the values of 5.414 into 1000 mm and we will convert the load into Newton, so it will be 1000 Newton divided by area is 10 mm square into the Young's modulus is 2 into 10 the power 11 Newton per meter square. So we will convert it into 10 the power 6 mm square. So meter square will cut. So now if we solve it, we will get 5.414 divided by 2 into 10 the power 3. So we will get 2.707 mm. The horizontal displacement at joint C will be 2.707 mm. Reference to the relevant NPTEL courses and video has been cited.